Okay, Dr. Ward, that's pitiful. Here's one. Okay, number one says that you have in her physics lab, Paige rolls a 10-gram marble down a ramp and off the table with a horizontal velocity of 1.2 meters per second. So here's her ramp. It rolls out that way at 1.2 meters per second. And that's Vx. Vx never changes because there's no gravity acting horizontally. The Vyi, the initial vertical velocity, is 0 because gravity hasn't had time to pull it off the table. The table is, or there's a cup out here, 0.51 meters away. And they want the student to calculate how tall the table is. Alright, well, dx equals bxt. So 0.51 meters is equal to 1.2 meters per second times t. So the time is going to be 0.51 over 1.2 meters per second. So if you do that math, let me turn on my trusty little iPad and get my TI Inspire hooked up. So if I take my 0.51 and divide it by 1.2, I find out that the ball is in the air for about 0.425 seconds. So if I want to know the height of the table, I say d is equal to 1/2 at squared plus vit. Now I'm talking about the x-axis, so this is going to be dy, and this is going to be gravity, and this is going to be the initial vertical velocity. We said that was 0. So the height of the table is 1/2 9.8 meters per second squared times 0.425 seconds squared. So if I take that 0.425 and square it and multiply it by half of 9.8, which is 4.9, I find out that my table is 0.885 meters tall. Number one is done. All right, let's move on to 2. So 2 says, James is standing on the ladder picking apples in his grandfather's orchard. As he pulls each apple off the tree, he tosses it into a basket that sits on the ground 3 meters below a horizontal distance of at a horizontal distance of 2.0 meters from James. So that's my vertical height. My horizontal height, 2.0 meters. And it says, how fast must James throw the apples horizontally in order for them to land in the basket? So we're looking for Vx this time. Well, we know that Vx is equal to dx over t. We know our dx is 2.0 meters. Now we've got to find our time. Well, you have an equation that says dy is equal to 1/2 gt squared plus byit. Well, he's going to throw it horizontally, so that's 0. So I have 3.0 meters is equal to 1/2 positive 9.8, because it's going to accelerate the apples down to the ground, t squared. So if I take 3.0 and divide it by half of 9.8, 3.0 divided by half of 9.8 is 4.9, and then square root that. The time of flight is 0.782 seconds. So 0.782 seconds he must throw the apples at 2 divided by 0.782 at 2.56 meters per second. And that takes care of number 2, madam. Let's go on to 3. 3 says, Emmanuel somebody, Zucchini or somebody, who knows, the famous cannonball at Ringling, blah, 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 was fired out of a cannon with a speed of 24 meters per second and an angle of 40 degrees to the horizontal. 40 degrees. And his speed was 24 meters per second. If he landed in net 56.6 meters away at the same height, so here's where he had some height, he went like that, and he landed at the same height, but 56.6 meters away, so that's my dx. How long was the gentleman in the air? Alright. So what I know is that I can do dx equals dxt. Dx was 56.6 meters. Vx, well, if you look at Vx, it's this little rascal right here. So I'm going to say the cosine of 40 degrees times 24 meters per second. So if I take this trusty little TI and punch in cosine of 40 times 24.0, his horizontal velocity was about 18.39. So that speed never changes because gravity never acts horizontally. So 56.6 divided by that 18.39. He was in the air for 3.08, or basically 3.1 seconds, equals time of flight. Okay, so there's number 3. Number 4 says a world record motorcycle jump occurred sometime. So-and-so did such and such, so he went a horizontal distance of 74 meters across a row of cars, assuming that he started and landed at the same height and was airborne for 1.3 seconds. What height from his starting point did this daredevil achieve? So I'm assuming that they're going to do this right here, and they're looking for that right there. I'm going to read it again and make sure I'm not having some issues. 1.3 seconds. Assume that he started and landed at the same height and was airborne for 1.3 seconds. What height from the starting point did this daredevil achieve? Okay, if he was in the air for 1.3 seconds, he went up for 0.65 seconds. The time up. And that's also the time down. So if I want to find the height that he achieved, I'm going to say d is equal to 1/2 gt squared plus vyit. Now, I can go back and try to find vyi, but there's really no need because I know that he fell down for 0.65 seconds. At the highest point, he has no vertical velocity because gravity has stopped him, so I'm going to get rid of that. And then I can simply say 1/2 9.8 meters per second squared. Time of flight down was 0.65 seconds squared. The time up, time down are equal. Distance up, distance down should be the same. So if I get my calculator and punch in half of 9.8 is 4.9 times 0.65 squared, he went up 2.07 meters. So distance up was 2.07 meters. Alright, so there's number 4. I think number 7 is going to be next. It says if a midnight rapper launches a roll of Charmin at an angle of 56 degrees with an initial velocity of 12.2, so draw your picture, 56 degrees, 12.2. Alright. What is the maximum height the unrolling Charmin reaches? And how long is it in the air? And how far down the yard did the roll land? Okay. So we want to find out first thing I would do is get my Vx, cosine of 56, times 12.2. And that would be Vx, and Vx never changes because gravity never acts horizontally. And then I would do my Vyi, sine of 56 degrees times 12.2. So if I use my trusty calculator here, cosine of 56 times 12.2, that one's going to be 6.82. And then the sine of 56 times 12.2. Oops, messed that one up. Sine of 56 times 12.2 gives me 10.1. Alright, so we want to find out how high it went. So I don't know any time yet, so I can just say, well, Vyf squared equals Vyi squared plus 2g dy. I want to find dy, so Vyf squared minus Vyi squared over 2g, which is going to be negative, should give me dy. So 0 at the highest point, because gravity has stopped it, minus 10.1 initial vertical velocity over negative 19.6, because 2 times g is 2 times 9.8. It's negative because it's being slowed down by gravity. So I should be able to square 10.1 and divide it by 9.6. I should get, or 19.6. I should be pretty close to 20 to 5. So we get 5.22 meters is dy. Alright, then it wants to know how long is it in the air, I think. Yeah. So I'm going to say that Vyf equals Vyi plus gt. Gravity is going to be 9.8 negative, so Vyf minus Vyi over g. So that's 0 minus 10.11 or 10.1 over negative 9.8. Oops, that looks goofy. Now this equation is really just Vf equals Vi plus At. I just changed all the variables to fit with the vertical motion that was going on. So 10.1 divided by 9.8, and they're both negative, gives me 1.03. That's the time up. But the time at the question asked me for the total time in the air, so that's 2.06 seconds. And then part C says, where did it travel, how far did it travel horizontally? dx equals dxt. Vx is 6.82, and t is 2.06. Oops, that should be a 6 right there. So 6.82 times 2.06 gives me 14.05 meters. That's how far it rolled. Alright, so that gets us all the way through 7. I'm going to get this one going on YouTube and we will move on.